Here we have a problem on derivative. Okay, let's go over the question. Use the limit definition of derivative to find f prime of 3 if f of x equals to 2 over 5 negative x. Okay, there is a function given over here that is f of x equals to 2 over 5 negative x, and we have to find f prime of 3. So using limit definition of derivative, first we have to find f prime of x. Once we get f prime of x, that is the derivative of f of x, we have to plug in 3 for x into the f prime of x. Okay, first let me write the formula for limit definition of derivative. Here we have the formula for limit definition of derivative. So now I'm going to continue this formula for the given function f of x. So that is f prime of x equals to limit h tends to 0. Okay, here we need the stuff which is equal to f of x positive h. But here we have f of x equals to 2 over 5 negative x. Okay, to get f of x positive h, what I need to do is in the given function, this x has to be replaced by x positive h. So on the right side also, here in this stuff 2 over 5 negative x, this x has to be replaced by x positive h. Okay, now let me replace this x by x positive h to get the stuff which is equal to this one. So we get 2 over 5 negative x positive h negative, and for f of x already we know that 2 over 5 negative x, that can be written over here, 2 over 5 negative x over h. Okay, so f prime of x equals to limit h tends to 0. We can distribute the negative sign to this x and h over here, so then we get 2 over 5 negative x negative h. When you distribute this negative to x, it will be negative x, and when you distribute this negative sign to this h, it will be negative h, negative 2 over 5 negative x over h. Okay, so f prime of x equals to limit h tends to 0. Okay, so to simplify the subtraction of two fractions, we have to get the common denominator, but here the denominators contain variable. So whenever I want to subtract two fractions where we don't have same denominator, and also the denominators contain variable, I have to do cross multiplication. That is, the numerator over here has to be multiplied by the denominator 5 negative x, then I'm getting 2 times 5 negative x negative, I'm taking this negative as it is. Now this numerator 2 has to be multiplied by this denominator, then I'm getting 2 times 5 negative x negative h over, so I have to multiply the two denominators now. So I'm getting 5 negative x negative h times 5 negative x. So everything as divided by this h. Let me continue here. F prime of x equals to limit h tends to 0. And here we can distribute this 2 to 5 and negative x, then I'll be getting 10 negative 2x. And the same thing, this negative 2 can be distributed to 5 negative x and negative h. When I do so, I'll be getting negative 10 positive 2x and positive 2h over 5 negative x negative h times 5 negative x. I'm just writing this denominator as it is. Okay, here in this step we have a fraction in numerator. So in denominator we just have h. I just consider this h as a fraction by taking denominator 1. So here we have a fraction, here we have a fraction. So we divide two fractions. Whenever we divide two fractions, we can take the fraction in numerator as it is, and we have to change this division sign as multiplication and take reciprocal for the fraction in denominator. So the reciprocal of this h over 1 is 1 over h. So now I'm going to change this division as multiplication, and I take the reciprocal of this h over 1, it is which is 1 over h. So I change the division as multiplication, and the reciprocal of h over 1 is just 1 over h. Okay, now we can do further simplification. This 10, negative 10 will cancel out, negative 2x, positive 2x will cancel out. So f prime of x equals to limit h tends to 0. And here we just have 2h, and 2h times 1 will be just 2h. And in denominator we have 5 negative x negative h times 5 negative x times h. I just multiply this denominator. And here this h will cancel out. So I get f prime of x equals to limit h tends to 0. We have 2 in numerator, and in denominator we have 5 negative x negative h times 5 negative x. Okay, that's all the simplification we can do in this function. So now what we can do is in the next step, we can plug in the limit 0 for h into this function. Okay, let me do it. So we get f prime of x equals to, so when I plug in 0 for h into this function, I'm getting 2 over 5 negative x negative. So here I find h. For this h, I have to plug in 0 times 5 negative x. Okay, so f prime of x equals to 2 over 5 negative x negative 0 will become just 5 negative x, and here we have 5 negative x. So when I multiply, okay, let me do it. So 2 over 5 negative x times 5 negative x will become 5 negative x the whole square. Okay, so now I got f prime of x. So f prime of x equals to 2 over 5 negative x the whole square. But our aim is to find f prime of 3. That is, in this f prime of x, I have to plug in x equals to 3. Okay, so let me plug in x equals to 3 over here. Then I'll be getting 2 over 5. Here also I have to plug in 3 for x, 5 negative 3 the whole square. Then I'm getting f prime of 3 equals to 2 over this 5 negative 3 is just 2. 2 square is 4. So 2 goes into 2 one times, 2 goes into 4 twice. So finally I'm getting 1 over 2. So the value of f prime of 3 is 1 over 2.